Good morning, everyone. My name is Rick Earls, and I'm the Senior Director of Industry and Innovation for Team Neo, and I will be your moderator today. Welcome to today's webinar entitled Connect Critical Assets. And this is the second webinar in a series of 5 that describes the steps necessary for a successful implementation of data-driven manufacturing, which is an emerging trend that when embraced by manufacturers, it's proven to drastically improve business performance and efficiency for those manufacturers. Now, let's do some housekeeping first. Just want to let you know that you have the ability to ask questions throughout the presentation using that button as indicated here, the question button. The webinar is being recorded, and you will be able to receive, or at least get your own copy of that presentation and the recording and assistance with regards to resources 24 hours after the presentation is completed. So let's go on to the next slide. I want to introduce you to Jay Ferran, who is our Senior Vice President of Industry and Innovation at Team Neo. And he's also, amongst many of the functions he performs, he's also the facilitator of the Smart Manufacturing Cluster for Northeast Ohio. So we're going to get Jay's going to give us a quick overview of the cluster activities and how they drive innovation in the region. Then he's going to give us a description of the webinar, the 5-step webinar, and again, what that means, how that is helping us drive innovation for manufacturers in our region. So Jay, you want to take it away?
Sure. Thank you, Rick. Really appreciate the introduction, and good morning, everyone, and happy Friday. Welcome to the second of 5 webinars that is part of this series. We're excited about it. We had great reception last week, and if you're not signed up for next week, I encourage you to do that as soon as this webinar is over. Our Smart Manufacturing Cluster of Northeast Ohio was formed simply because we're a manufacturing region, 7,700 manufacturers in Northeast Ohio. And we recognize that technology is going to be a great contributor to growth and success for many of the companies. So we formed the cluster. The cluster is made up of manufacturers, solution providers, service providers, investors, incubators, academia. So we have a real good, great cross section of people that come together to accelerate the rate of adoption. So what's the purpose of the cluster? It's that, accelerate the growth and competitiveness of the Northeast Ohio economy through industrial IoT implementation and innovation. So how do we do that? Well, this webinar series is a perfect example of that. We connect IIoT knowledge, experience, tools, and networks with manufacturers that generate demand, increase productivity, and spur product innovation. When you go to our website, smartmanufacturingcluster.org, what you'll find there is readiness assessment that you can use. It's confidential. We provide a use case database that's comprised of use cases from a wide variety of solution providers. And we provide a roadmap, a commercialization roadmap that indicates that there is up to $14 billion of incremental GDP available in Northeast Ohio if we have a reasonable level of implementation of IIoT. So as you can see, this webinar series is an example of what the cluster is capable of. And what we have really worked hard to do in this series is bring both a manufacturer and a solution provider to the table to share a use case. We think this is the best example for each step of the journey that you will take as you implement IIoT. So the emphasis is on operational excellence, improving efficiency and productivity of small and medium-sized manufacturers. And one thing that we've added is addressing the influences of COVID-19. And we'll try to highlight that along each step of the journey. So thank you again for being here. Really appreciate your participation. Please be an active and engaged participant. And with that, I will return it to Rick. Thanks so much, Rick.
Thank you, Jay. I want to give you a little bit more a detailed overview of the process itself quickly, and then show how it at least drop down to more of the detail specific to the webinar presented today. So let's talk about the 5 steps themselves. So we have prepare, connect, visualize, analyze, and optimize. And we've already had prepare webinar. And again, that's probably one of the most important steps to start with. And you'll see even today that when the manufacturer's describing their use case, they talk about that preparation stage. And again, it's basically just understanding how data-driven manufacturing concepts will impact your business or could potentially impact the manufacturer's business, and then do an assessment and put a plan together. And now when we talk about steps 2, 3, 4, and 5 are basically the implementation of that plan you put together. So today we're going to also be talking again about connect, and that being again finding or connecting all the critical aspects of your business, assets of your business together, and collecting that information both in-house or maybe even to the cloud, but anyway, setting the stage for harvesting the value from it. Then there's the visualization stage. Again, it's one thing to collect the data. It's another thing to be able to share it with the critical staff and workers within the organization. Then we want to be able to analyze that. So look at the metrics now, especially their key performance indicators, and see where you can find opportunities to improve and optimize. And then, of course, the optimization stage is once you've got all those previous steps in place, it's now time to start taking corrective action on a real-time basis, and that's what optimization is all about. So let's go to the next slide. So let's talk a little bit more about Now Connect, because again, that's really the focus of this webinar today. And so, as I said before, it's basically connecting all the old and new machines together and sharing that data to the corporate network, identifying your KPIs and the sensor schemes to support those KPIs, then using gateways and whatever is necessary to acquire basically the data and find a linking heartbeat between all the critical assets. So it makes it a whole lot easier to do analytics. Figure out what your data storage is going to be. Both it could be in the cloud, or it could be a local, or it could be a hybrid. So you've got to make up your mind. We'll be talking about that again today. 2, blending the information, and this is a big issue. How do I get the IT in the front office working with operational technology in the back office, and especially exchanging data between the 2 centers? And then, of course, we wanted to address cybersecurity. Next slide. So the agenda for this activity is I'm going to give you introductions first. Then Kurt is going to be talking from a manufacturer standpoint about his use case and how it led to the implementation of their data-driven manufacturing and how they started their journey. And then we'll fall into the specific efforts that were necessary for the connect phase of that implementation. And then we'll have a questions and answer session at the end. So again, prepare your questions, hurry up and type them in. We'll be putting them into a file and then start answering them as we get to that section. So with that said, let me introduce Kurt Schroen. He's a senior financial analyst at Jergens, which is a manufacturer of a standard tooling components, devices, and working equipment. Also, who will be talking is Francis Martin, who's COO and Vice President of VantageOne, a solution provider of custom software and on-demand application services, again, to drive digital transformation. And then John Rattray, who's Senior Sales Executive for MEMEX, and a solution provider that also specializes in customized software consulting and development and the Internet of Things solutions for data-driven businesses. So with that said, I pass it on to Kurt.
Great, thank you, Rick. So, like you said, I'm Kurt Schroen. I work here at Jergens. We're an industrial manufacturer here in Cleveland, Ohio. John, if you just want to go to the next slide. So actually, if you want to go back to the other slide real quick. So one of the things that, we've talked about internally as we talk about anything data-driven manufacturing is this crawl, walk, run approach. So that's kind of what those little images there represent. So we are always trying to incrementally do better than what we have. So that's kind of where we're always on this journey and always trying to get better. But Jergens is an industrial manufacturer based here in Cleveland, Ohio. We have 3 different divisions. Our main manufacturing division, which I'll be talking about mostly, has 3 different divisions, business units. And so lifting solutions like hoist rings, work holding solutions like vices and other quick change applications, and specialty fasteners, which you can see a quick lock pin there. So for quick change applications. We also have a distribution division and an automation division called ASG, which also produces precision torque screwdrivers. So for just to kind of level set what IIoT or Industrial 4.0 or data-driven manufacturing, there's lots of terms, and you've probably heard 5 or other more of those terms. To me, they all just relate to data. So data coming in, using that data to make better business decisions. And so that's kind of really where we're starting from the ground up from all of these different things. These are all relatively new technologies, but at the same time, they're old technologies that are just learning new ways and better ways to collect that data and process the data and interpret the data and use that data to make, like I said, better business decisions. So I think it's important to level set where we were when we first started this kind of journey. And so as an industrial manufacturer, we have an on-premise install our ERP of Sightline Infor, or Infor Sightline. We have a mixture of ways that we load our programs onto our CNC machines. So a lot of internet connected, no DNC software, and a lot of different ways we do that. Some of our machines, including one, has Ethernet output to current machines that we're using for different things. Most machines did not have a hardwire connection to the machines, so some of our newest machines might have had some, but most do not. And then we have terminals around the floor for ShopTrack, which is another program created by the lloT companies that we use that does our costing. So operators would walk over to these terminals, clock in for a job, go back to their machine, perform the job, and then come back to the terminal and clock out. So those are some important things about our environment that led to some of the decisions that we made, and as you'll see going forward. So I think if you have a very different environment, you might have a very different solution criteria and different selection of how you might best utilize this. So in terms of Jergens, how we prepared for this data-driven manufacturing, it started, as you can see, back in 2018, at the end of 2018. We attended Blockland, which has nothing to do with a lot of this stuff. But again, it goes back to this idea that all of this is somewhat connected just around data and how do you use it, how do you process it. And so it started us talking about where do we want to go, what do we want to do, how do we want to use ourselves in the future. And so we then started attending some of the cluster events put on by Team Neo and seeing a lot of different ways other people were talking about and using IoT, machine monitoring. And so we said that this is a corporate initiative for us to figure out how we want to use this. And so we held lots of meetings internally with our executive team, our supervisors, our operators, our IT, all different organizations throughout or all different levels throughout our organization to see what they saw as problems and how can we help solve those problems with more data and with more technology. And so we also had Hitachi come in and do a smart manufacturing workshop in partnership, I believe, with Team Neo. And so they met with us, kind of ran a lot of those same scenarios with those different people. We had operators all the way through, including and our IT team. I think it's very important to have all those people connected from the very beginning. And so then from there, after we kind of had an idea of what we wanted to do, we started our vendor selection process. And so these are some of the different things that we saw as we were starting that process of key advantages and disadvantages. That we had C-suite buy-in, that this was a corporate initiative. We understood that we're going to be investing money, and we understand what we hope to get out of it based off what we're looking to solve. We have a lot of manufacturing engineering talent and different project managers to drive this project. Disadvantages, we do have a lot of older legacy machines. So we manufacturing for over 75 years, and some of our machines are still from those 1940s. We still have some of them on our floor. And so we also have brand new machines that went in this year that have the latest and greatest 5-axis machining capabilities. So we don't have a lot of data across those different machines from a downtime environment. We know when things are down off the gut feel of what machines are up and down more. We produce in a high mix, low volume environment, which is a challenge for a lot of different things because we have a lot of setups, we have a lot of changeovers, a lot of different ways that we're manufacturing different parts every different day. And on the right is the output of the Team Neo readiness assessment, where we were at when we first started this kind of process, just to give everyone a level set. And so these were some of those pain points and metrics that came out of our conversations with people of, we don't know when machines go down. We don't know what we don't know. So no data about why. We felt like we were very reactive to a lot of our notifications and not being able to be active and proactive to solve some of those. Our job counts as a result of that, of the manual input of data, were slightly inaccurate. And the data was not very timely. So we had some reports, but they were weeks old and stale. It was hard to act on those different types of reports. If operators had to track somebody down for a machine being down, different things, they left their machine, more idle time, and really no good way to get in touch with their supervisors and different things like that. So what we identified as some things we wanted to get out initially from this kind of process was we wanted to see utilization, total part counts, uptime, downtime indicators, and downtime reason tracking. We thought with those different things, we'll definitely see an improvement in our OEE, improvement in our utilization, and able to drive better results. So from there, we kind of took all those different things and assembled what we kind of wanted to do as like a scorecard for different vendors as we started to talk with them. So these are just a few of the things on the left that we wanted to make sure we had access to all the data and it was secure, different alerts, buzzers, easy ways for the operators to interact with this system. So they're used to a current system in ShopTrack, and we didn't want to have to pull them off of that, create multiple systems for them to log into, multiple ways for them to interact with the things. So we wanted to make sure that it was easy and intuitive for them. And then we also identified a list of nice to haves in terms of some of the different things that as we started talking to solution providers, seemed like it would be more challenging based off our environment. So we have some manual assembly stations that use just screwdrivers to assemble parts. And so how can we tie into those when there's no machine that they're actively working on? Also, physical tracking of tool life as operators change out tools and things like that. So one of the big decisions we had as we started looking into the different vendors was on-premise or cloud. I don't think there's a right, from my personal opinion, I don't think there's a right or a wrong choice. I think it depends a lot upon your environment. For us, our ERP is on-premise. Most all of our data is on-premise. Most all of everything we do processes through this facility on-premise. So for us, on-premise was a very important aspect of that. We are, as a company, somewhat cloud resistant, just in terms of making sure we have our hands on all the data. But I think there's a lot of pros and cons to both sides of this. And so I think it's really a comfort level and a factor of your environment of which way to go. So after we decided we were going to be implementing a solution, we looked at our physical network and infrastructure and saw what we need to do to change to be able to fit our vision of what we wanted. So you can see that that's a floor plan of our shop floor and a representation of what we did in terms of additional wireless access points, twin cable drops, so running actual physical hardwire to all of our machines with twin drops to be able to connect to a machine, be able to connect to other things as we were doing that. So we you'll see it later, we initially only connected 10 machines, but it turned out as we are having our conversations with our vendors that helped us run these lines, it was just much more efficient to run them all at one time rather than, so we're kind of future-proofing where we know we're going to go in the future, even though a lot of these are underutilized right now. And with those additional cable drops, we created a new VLAN network for them to operate on. So it's just the machines running through those networks and back to our servers with no outside connections. This was important for us from a cybersecurity standpoint, and also just a best practice that we'd heard as we talked to different vendors and other people in the industry who've done similar initiatives. So as I said, we've started prioritizing with 10 machines, and so we called these our 10 easiest machines to connect to, because a lot of them already either have an Ethernet port or in conversations with our vendor MEMEX that they had boards, as you can see on the left, that could easily be installed onto our machines to allow those direct connections. And so we connected transfer machines, mills, and lathes across our different product lines to make sure, as we're starting to see output from these, we can see impact across multiple business lines, across multiple products, and be able to see where we are getting the most value out of those things. So 3 of our 10 machines, we had direct plug and play. We just plugged an Ethernet cable into, and basically had no other setup that was needed. 7 of our machines needed some additional hardware or software needed to the machines in terms of those boards. But for none of these 10 easiest machines, we added any additional sensors. So these machines are all relatively newer, and so they had a lot of the capabilities to be able to collect the metrics that we wanted without any additional sensoring. So in terms of onboarding and connecting, one of the things, is connecting to the people. So this is from a people standpoint, what we went through when as we were installing was we had 10 hours of training across different dashboarding, reporting, admin, features, ERP integrations. So this is from operators to supervisors to management of how they can best utilize these. And not everybody went through all the different trainings because they as it was applicable, but they're all recorded. We can all go back and watch them and have a good resource there. So that is kind of how we went through the connection. Not everything went as smoothly as can be expected. Some growing pains. I will say that most of these growing pains were on us. So I know the last session that Team Neo put on was prepare, and prepare is very important because that led to some of these connection issues. So I mentioned our Sightline and ShopTrack integration that our operators use. So we chose to integrate with ShopTrack directly using APIs from MEMEX. This causes a little bit of more of a hurdle in terms of the integration, but we think it's going to be a much better solution for us rather than operators having multiple portals to log into. So all the different reporting that we can get out of MEMEX, all the different data collection features of MEMEX, we can do directly in our ShopTrack integration. So that's something we're still working on. COVID's kind of put a little bit of a damper in some of that. We were on schedule to have that installed in March, and it's just a little bit of getting people in, getting work done is kind of a challenge. But One machine was not able to be connected, so I mentioned our Ethernet port was being used by our QC Calc software. This is our brand new, newest machine, but unfortunately, right now, based off what we have currently in place, we haven't been able to get that installed. So something on our end we're working through. Two machines don't have any part counts, so when MEMEX came out to install, we as a company didn't have the schematics for those machines. So it's hard for MEMEX to be able to point to the right trigger, the right relays, everything like that to get the machines calculating part counts. We've since found those, and so we're scheduling a time to be able to get all that working. Additionally, two machines, inaccurate part counts. So like I said, we're getting signals from these machines. Well, you can count parts in multiple different ways. So this is something that we had a learning from. So in one of our machines, we were counting chuck open and closed, and that meant that we had a good part or a finished part come out of it. The operator figured this out by just toggling open and closed, and he alerted us to it and said, hey, this is going to cause some inaccuracies in our part count because sometimes I have to open the chuck and close for other reasons. And so now we're working with them to make sure we can get a better indication of part count. This is what the solution looks like on our shop floor. So there's multiple, I know John's going to talk through different dashboarding solutions, but this is what it looks like on our floor. We have about eight monitors out there and displaying this information. Our integration with our ERP, like I mentioned, operators are going to have their own tablet computer to work from, enter job start, enter quantities, and enter their downtime reasons. So this is one of the biggest things we're really looking forward to be able to track why machines are down, not just that they are down, which is currently kind of what we're doing. And this is our next steps in terms of connections. So we're going to finish with our ERP integration, begin our continuous improvement plans, continue with those, and work in stages of about 10 machines. That's just how we feel comfortable rolling out until we have a full 4 rollout. And then we'll look to use additional pieces of why we have our data in terms of optimizing for preventive maintenance or lead times. And this is, kind of where we have that from a continuous improvement plan. I know other people are going to touch to this, and these are also aligned really well with the Team Neo steps of the webinar series. So I know you'll hear more about a lot of these different things in other sessions. So appreciate it, and feel free, if you have any questions, to reach out. Thank you. And now over to Francis.
Thank you. Hi, my name is Francis Martin. I'm the Chief Operating Officer at VantageOne Software. VantageOne, you can go ahead and go to the next thing. VantageOne is a local software development company in Eastlake, Ohio. We have programmers available for custom projects and contract work, full or part-time. Our role in the smart manufacturing cluster is that of an integrator. And we are the Northeast Ohio sales partner for MEMEX. We sit at you can go to the next slide. We sit at the convergence point of information technology and operating technology. Basically, what that means is we have programmers that write software that help your ERP system or your production management system communicate more effectively with the MEMEX equipment, such as what they're using over at Jergens. Planning for this connectivity is important. And John Rattray is going to be next discussing connectivity in his presentation.
Okay, good morning, everyone. So I'm John Rattray from MEMEX, and contact information is there. In the interest of time, I'll move forward. The discussion topic today is all about connections. And it's the most important area is being able to get the data from the machine. And think of the machines as streaming live data all the time, continuously. It's a machine, it just outputs the data. But to interpret the data and take the logic and putting in the right way is the real trick about connecting and then presenting that information and visualizing and then acting on the information. But you first need to connect to the data. How does it come alive for smart manufacturing? Well, it's evidence-based data on the shop floor. It's work orders and scheduling with ERPs. It's work and process. It's driving your costs out by understanding what's happening, process improvement, continuous improvement. And I like to say it's really vertical and horizontal integration, shop floor to top floor, and then horizontally across the shop floor with everyone communicating about what's actually happening in real time, dashboards, e-alerts, messages, all kinds of things about exactly what's happening on the shop floor. The benefits can be significant. It's not any one thing, it's a whole bunch of little things added together, 1% here, 2% there, 3% there, root cause analysis, understanding about operators, functions, and productivity. And typically you're seeing the 10 to 50% improvement in productivity, which is why it's Industry 4.0 or the next industrial revolution. How do you connect to the machines? Well, there are various different software protocols, and there's various different legacy hardware adapters that Kurt talked about and showed you some there that they're using. There's operator information, there's business systems, ERP information. All this comes together in this coordination of all the various different inputs. If we look at the ISA 95 standards, and I suggest people do understand this, there are multiple different levels. The machine is level 1, for instance. An ERP business system is level 4. And then you have level 1, 2, and 3 in between. Level 1 is the connection, and that's what we're speaking about today, the various different adapters. But level 2 is the distributed control system or the agent, and then level 3 is the application or the visualization and dashboarding system, which you're going to see in the webinars 3 and 4 and 5 in terms of details. So one of the key things that we do as a premise is we make sure that no machine is left behind. Level 0 for the machines, but level 1 is the connections, and we can make sure that any machine is connected regardless of age or vintage. 35-year-old machine with no serial ports or Ethernet ports, we still have a solution. Typically, it's a software solution. If you bought a new machine today, you would have MT Connect as an industry standard. It only became popular in 2008. That's when the MT Connect Institute was founded. And that set an industry standards and really made this whole world of industrial Internet of Things come together. OPC has been around for a long while, so for PLC-based machines, you can use OPC to connect to them. If you have FANUC controls, you can use their Focus 2 software capabilities. If you have proprietary protocols in the controls and you can access them through the Ethernet, we can pull that out and make sure we get information directly into the dashboards. But on the older legacy machines, there are solutions, one of which we're showing here is our AX760-MTC. It outputs in MT Connect, industry standard open source protocol in terms of communications. It picks up signals from inside the machine, and I'll show you pictures as examples, and then an onboard processor here will then communicate that information in MT Connect code to make it available for people. So a simple little example, here's one of our boards installed on a particular machine. You can notice the RS-232 cables going into the I/O link of this FANUC 18i control. We pick up about 100 different data elements directly from the I/O link here of what's happening on the machine and the control that gets processed and read here, read only, no control capabilities. And then we can convert that to MT Connect and send that out so it's usable then by any type of applications on the shop floor. Other examples, you can see we're connected into the back end control cabinet of this particular machine, and other pictures in terms of control and connections. In this particular panel saw, we're right into the backplane where we're picking up part counts, in cycle, e-stop, alarms, various different codes, wiring them directly into the machine, and then being able to output them in MT Connect and communicate in terms of the software. There is many different types of hardware stacks that you could look at in terms of various analog or digital connections, various different boards. It depends on each individual machine. A good vendor like ourselves, we've done about 20,000 installations of hardware in terms of connecting machines. So it's all about understanding each of the individual machines. We have the experience, we know how to connect and what we can do, and we can make that work in terms of going forward. As Francis talked about, the kind of convergence really of 3 data streams, IT and OT. The typical traditional way is operator entered data. barcode scanning, maybe entering it in on clipboards and then later into Excel, whatever. You're capturing data from the operator, but that has its limitations in terms of timeliness and accuracy. Add to that machine data of what we're doing now, real-time streaming and up to the second in terms of what's happening, and you add the operator data with the machine data, you get much more accurate information about what's actually happening. Then tie that together with your business systems data from ERP environments, and then you can start to share that information as a platform or portal on the shop floor that many people can access in terms of various different other types of applications. The business case benefit here is visualized. If you look at the center line here, the green, typical companies running a 40 to 50% utilization, where world-class on the right is 85% OEE or better. There's a lot of time wasted in the machine shop, reporting, job, and maintenance, the classic big five losses. Understanding these means you have the ability to get to continuous improvement and improve the efficiency of your operations. And that's what our MERLIN performance management model is all about. Data collection plan at the machines, track it down to the actual individual item that it is, where it is, all the various details, then put together a reporting plan so that you can visualize in webinar 3 and then take action, webinar 4, in terms of continuous improvement and then ultimately profitability. Just quick graphics. Here's some dashboard viewing of these MPMM categories: machine, shop, job, maintenance. You can look at actual versus target baselines and information and dashboards. You're going to look at analysis of information through reporting and real-time information. It's all about tying these things together, various different dashboard views. It's going to make sense to look at things. Plant utilization type of views, Excel charts. These are all sort of real time in terms of tracking things together. And in fact, in this particular one, this is a real-time chart that's actually running today. You're going to see it jogging from right to left, but we've got things like rapid override, feed rate override, spindle override. You know exactly what's operating and what's happening to the second, and this is all historically tracked. So now you've got reporting capabilities, and that's all generated from the machine without any operator intervention. It just works in terms of runs. And you may look at things in various different ways, such as the status across the various different machines that are out there, graphical layouts, or maybe you want to have detail of an individual machine, or maybe you just want to have OE metrics that tracked across all various different types of machines. Easy enough to look at information, know exactly to the second in terms of what's actually happening. The value proposition is 10 to 50% improvement in efficiency, typically a payback in 4 months areas. That's a whole smart manufacturing. If you can measure it, you can manage it. Key efforts involved there. So now I open it up for questions and answers. I think Rick was going to come on with any questions.
Yep. So we have an interesting one right off the bat from a representative from Daniel Penn LLC. And he's talking about other applications than just OEE, for that matter, or asset utilization. So how important are comprehensive, he calls them PM procedures, I think it's predictive maintenance procedures, in implementing these types of systems? So Kurt, did you think about that aspect of utilization for your data and the way you?
We definitely did. Yeah, we definitely did. That was one of our criteria for when we were looking at what vendors we could use. And so that data, certainly not something out of the box, that was our goal. Our goal was not to do preventive maintenance or predictive maintenance off the bat. We wanted to make sure we had the data collected and capable to, in the future, be able to do some of that predictive and preventive maintenance. But I think it was important for us to identify what our goals coming out of this were. And so one of our biggest goals was utilization and increasing uptime, increasing identification of downtime reasons and eliminating those. And as we are collecting that data, one of the big ways I think for predictive maintenance to be valuable is you have to have a large set of data and a large set of errors data. And so we don't have that currently. So, to think we were going to go from there and to having that in a couple months was challenging for us to think that. So that's what we wanted to make sure we focused on. And then in the future, that is certainly a goal.
Excellent. Good. Thinking about other things like tracking WIP and things like that, or optimizing WIP, those other types of applications beyond just predictive maintenance then too, maybe even occupational safety? Any of those things come to mind?
I mean, definitely any and all the above. It goes back to,
Excellent.
for me, this is all about data. Once you have the data, collecting the data is the first step, and then being able to have it so you can analyze it is the next step. Many different ways you can analyze it for different goals.
All right, good. Another question now. Can you elaborate on the financial aspects, of course, costs and things like that associated with your proof of concept, and any of those aspects for data-driven manufacturing project, like ROI? Again, did you go through that process then of justification?
We did, yes. And so for us, from a cost standpoint, that was definitely one of those criteria I mentioned about when we were looking at vendor selection. So for us, from an ROI standpoint, we were looking to how can we improve what we're doing now. And so we didn't have a target. We didn't have a goal in mind of what we wanted to see from an ROI standpoint. We know this is the future, and we were kind of bought in to say, hey, how can we make this and where we're going to look to see it have that value.
All right. Francis, do you have anything to add to that?
No.
All right. All right. Moving on, number 2 then. Another question here is, how does data-driven manufacturing prepare a manufacturer for the challenges imparted by COVID-19? And Kurt, can you pull something together for that?
Sure. So
cost, for example.
Yeah, we obviously weren't. I don't think anyone was predicting COVID-19 or prepared for it. So for us, one of the big challenges was we were an essential manufacturer, so we needed to stay in operations. And so for us, we were able to lengthen our schedules. We were able to stretch it out, work over 7 days, 24 hours, to really be able to spread out the workforce, physically. And so with a solution like this, we were able to see kind of how we're operating on a weekend basis, how we're operating on a night basis, how we're operating on a third shift, which is brand new for us. So we're able to see a lot of those different things in real time.
Excellent. Good. How about, here's another question. Will data-driven manufacturing make the manufacturer more vulnerable to cybersecurity threats? And what are, I guess, the solution providers and manufacturers doing to mitigate that risk? So, John, you want to start with that?
Certainly. Being connected on the shop floor opens you up to that cybersecurity, but there are tools that are being built, certainly available by your network people like Cisco and so on. But there's also a new invention out there called a smart box, which is an intelligent managed switch connected directly to the machines. And it's meant to really isolate the machine so that for example, if somebody puts a USB stick into the machine, that switch will shut down the connections and the whole network, recognizing it's something that shouldn't be there. So the power is there in terms of all kinds of cybersecurity connections. It's important to make sure that that's done. Simple things like VLANs and isolating your shop floor networks are an excellent way to do it. No outside connections, all those sorts of things. The technology is there to do it.
Very good. Well, I think we should maybe have, how about one more question then, real quick. John, are there machines you connect to?
Excellent question. In general, we can connect to any machine on the shop floor, be it welders, be it assembly stations and workstations. It's all about a question of what data can be collected and what mechanisms can be done. So in general, we can connect to any machine on the shop floor. And machines that you can't connect to are where there's no signals or no data that's worthwhile to. There are some brand new machines that are, medical devices for very specialized, and there's no connections or controls. It's all electronic. That's a difficult one to do, but you can get certainly an in cycle in terms of when it's running or not. And those are some of the basics, and those in themselves are very good. So it's all a question about what type of data is available at the machine in terms of going through the discovery process to put that together. At the end of the day, if we look at overall cost, it can be highly scalable from a deployment anywhere between $3,000 and $6,000 per machine, and you can scale it by functionality as well as by individual machines. So the power here is easy deployment because of the scalability and the cost factor here for everybody to work with it.
All righty. All right, so we should probably move on to closing.
So why act now? Well, typically it's a 10 to 50% improvement in efficiency, and it's really strategic competitive edge for companies where visibility gives you your overall efficiency. There's a lot of recommended material here. This will be available certainly after the session, so you can access these, and they're all linked to various different areas to work with. And I think, Rick, you want to go through the closing comments.
Yeah, just to remind you again, so you'll be able to get a link that'll be emailed to you that will give you access to the presentation as it was recorded, the materials used for the presentation, and also that list of resources that John just shared with you. Remember that the next seminar is part 3. It's visualization, real-time data, and that's on June 19th. So remember to sign up for that one then too. You can register at that link there. And then I'd like to say on behalf of the Smart Manufacturing Cluster and presenters, thank you for joining us today. It was excellent. Lots of insight provided here, realization of an actual project, just great. I appreciate all your input and support. And with that said, I guess here's some contacts you can use if you'd like to get further information. And again, that will be included with the presentation material, so you should be able to have access to all those key people that you saw today make those presentations. All righty, I think we're done.
Thank
Great.
you.
Thank you.
All righty.